Welcome. In today's video, we are going to be discussing addition of whole numbers and all properties around it. So, what are whole numbers? Whole numbers are numbers starting from 0 and just adding 1 to each previous number. So 1, 2, 3, and so on. So what we did is we started from 0, and to get the next consecutive number, we add 1. To get 2, we add 1 to 1. To get 3, we add 1 to 2. This can be represented on a number line. So we draw our line, start from 0, and we put these dots, equal distance. We put this arrow pointing to the right, and we start counting 1, 2, 3, 4, 5, 6, 7, 8, and we can do this to infinite. So my question is, can we say that 112 is a whole number? The answer is yes, because if we start from 0 and keep adding ones, we will end up reaching the number 112. Now, is 2.5 a whole number? No, because no way we can keep adding ones and reach 2.5. No, after 2, we get to 3, and 2.5 is in between 2 and 3 and makes 2.5 a decimal number. So 2.5 is not part of whole numbers. Now that we know what are whole numbers, let's start adding them. We will start with single digit whole numbers. So single digit whole numbers are numbers between 0 to 9, and two digits are from 10 to 99. Three digits are from 100 to 999. Three digits, 1, 2, 3. Three digits, 1, 2, 3. And we do have more digits. You can guess. You can keep adding 4 digits, 5 digits, and so on. Now let's go back to our addition. Let's add two numbers, 3 plus 5. They are both single digits. So if you know the answer, you tell me it is 8. But if you don't know the answer, let's figure it out together. There are many ways of doing this. You can count your fingers or any object around you, or you can use something that we call number line. First of all, let's try to count objects. You can draw like stones and count them. For this example, if you want to use the counting method by drawing stones, you start with the tree. So 1 stone, 2 stone, 3 stones. So this is for these 3. Here we have 5 stones. 1, 2, 3, 4, 5. So these stones are for these 5. So addition. Once you do this, you count all stones that you have, and the total amount of stone will give you the final answer for your addition. So by counting, we have 1, 2, 3, 4, 5, 6, 7, 8, and I have 8 stone, which is same thing as this. Now let's use our number line method. So we draw a line. The first number is 0. We don't forget our arrow pointing to the right, and our first count here is 3. So we will put 1, 2, 3. 1, 2, 3. And to 3, we are adding 5. So from 3 here, I will count 1, 2, 3, 4, 5. So what is this number if I start counting from 0? So let's count it. I have 0, 1, 2, 3, 4, 5, 6, 7, and this number is 8. So from our number line, we end up having 8 also. So let's add now 6 and 4. You can pause the video and try to solve it. What do you get? Okay, let's see it together. We are going to use the number line to solve it. So I start my number line with my arrow pointing right there. The first number here is 0, and I'm adding 4 to 6. So I will be counting 0, 1, 2, 3, 4, 5, 6 right there. and I will be adding 4 from here. 1, 2, 3, 4. So what is this number right there? So let's restart counting from the beginning. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my answer is 10. Before we continue, try solving this problem by yourself. Put the answer that you get in the comment section. First problem, solve 0 plus 9. Second problem, solve 3 plus 8 plus 1. Third problem, solve 4 plus 0. Put the answer that you get in the comment section. Moving to multi-digit addition, let's add 75 and 104. What will be the answer? So what we do is we line them vertically, one on top of the other one, so that the ones placed the rightmost are directly on top of each other. So the 5 here is on top of the 4. And we do the same thing for the other numbers. 7 on top of 0. Here we don't have anything, and we put the 1. So once we align them, we start adding the digit in each place from the right to the left. So in this case, we will be adding the 5 to the 4, and we will have 9 right here. We put it down there. We align them. See the alignment? We add the next 7 and 0. We give us 7. And here, we don't have anything. That means there is a 0. We can replace it by 0. It's an invisible 0. Plus 1, still have 1. And our final solution should be 179. Another example, let's do 249 plus 13, right? We start 9 plus 3. That will give us 12. Or in this case, we have our result, which is 2 digits. 12 is 2 digits. So what we do is we write the rightmost digit right here, 12, I'm into, and we carry the 1 to the next place. Have this place, I carry to the next place. I put 1 on top here. And I perform the same addition now between these three. That will be 1 plus 4, which is 5, plus 1, which is 6. 6 is 1 digit, there is nothing to carry. So I move to the next place and I found 2. 2 plus nothing equal 2. I have 262, which is my final answer. Now try this. 347 plus 1633. What will be the result? Line it up correctly, add it, and put your result in the comment section. Now that we know how to add single digit whole numbers and multi-digit whole numbers, let's talk about some properties of addition. Let's do 3 plus 4. The answer should be 7. Now let's flip it around. Let's do 4 plus 3. The answer is still 7. You can verify it, you can prove it by doing the number line. Let's do another one. 10 plus 6. That will give me 16. What about 6 plus 10? That will give me also 16. So from these two sets, we can see that changing the position in the addition doesn't affect the result. We change the position, but the result is still the same. That's the reason why we call this property of addition commutativity. Second, let's look at another set. Let's add 2 and 0. That will give us 2. If we do 0 plus 4, that will give us 4 back. If you do 7 plus 0, we should have our 7 back. So any whole number plus 0 or 0 plus any whole number should return the same whole number. And therefore, we call 0 additive identity. Finally, to solve 2 plus 1 plus 5, we can do this. We can start adding 2 plus 1, which is 3, and plus 5, which is 8. So if we want to rewrite it, we can rewrite it as 2 plus 1 plus 5. Or we can come and do 2 plus combine 1 and 5, which is 6, and add 2. So 2 plus 6, we still have 8. So we can write it as 2 plus 1 plus 5. Now if you look at it, the position of the parentheses doesn't affect the result. The result remains same, but the parentheses can change around the numbers. So that property is called associativity. So we will stop here for now. Don't forget to like, comment, share, subscribe. Let your friends subscribe, and I will see you for the next topic.